It's Bianca Contreras. For my chemistry final exam, I'll be doing the elephant toothpaste experiment. The experiment is called elephant toothpaste not because it's actually dental toothpaste for elephants, but because the chemical reaction seems big enough for an elephant. It's popular in households and amongst kids because it's fairly easy to perform. Here are the materials, and make sure to pay attention because I'll be going over them quickly. First, put on any gear, safety glasses or gloves. Be cautious of hydrogen peroxide because it can irritate your eyes. I'll be using a tray to make sure my station won't be messy. You don't want to ruin your dining table or your mother's precious table cover. With half a cup of hydrogen peroxide, carefully pour it into a clean empty glass or bottle. Pour some dish soap into the glass and mix. We're testing the 3% hydrogen peroxide and 6% hydrogen peroxide. We'll be observing the difference between them, but the process will be the same for each. You can add color to the experiment using food coloring. Mix a few drops into the hydrogen peroxide. Using a measuring cup, mix 1 tablespoon of yeast to 3 tablespoons of warm water and stir for about 30 seconds. Now we'll pour the yeast mixture into the bottle and step back. Now, keep in mind, just because it's called toothpaste does not mean you can brush your teeth with it. Once finished, pour the mixture down a drain. The elephant toothpaste experiment, as you saw, produces a foamy substance and it goes as long as there are hydrogen peroxide and yeast left. The chemical reaction that just happened was the decomposition of hydrogen peroxide, which is an antiseptic that kills bacteria to clean cuts, available in different concentrations. From what was H2O2 yields to H2O, also known as water, and O2 as oxygen gas. Ooh, there it is, balanced with 2 hydrogen peroxide and 2 water. However, the actual decomposition is slow, so to make it quicker, the yeast and warm water serve as a catalyst that makes its decomposition rapid. See, yeast contains the enzyme catalase, which specifically breaks down hydrogen peroxide faster. Catalase is in nearly all living things exposed to oxygen. Thus, we have this chemical reaction. Additionally, the speed of the decomposition further depends on the concentration of hydrogen peroxide. Obviously, the higher, the faster. You may have noticed that between when I use 3% hydrogen peroxide versus 6% hydrogen peroxide. The decomposition in this experiment is also exothermic, meaning energy is given off in the form of heat. Lastly, oxygen gas forms bubbles that would leave the liquid and pop shortly. When we added dish soap, it produces additional surface tension, allowing the bubbles to get trapped and create the foam. And that concludes my chemistry experiment for elephant toothpaste. Keep safe and have a wonderful day!